But really excited to talk about liver health today, and what that means, because as you guys know, we live in a very industrialized society. So like our food being so industrialized, our water is, laced with a lot of different stuff in there that ideally wouldn't be in there if we could help it, right? So there's just all these exposures that we have to these toxicities in our environment. And the liver is the thing that's, most accountable to ensuring that as we're consuming, as we're exposed to these things, that they're getting detoxified, eliminated from the body. And so the liver is of utmost importance in that regard. So we're going to be talking about liver health, what you can do to improve it, some free things that you can do to identify if you have any sort of liver issues. And then we're going to talk about something really interesting that Dr. Jasbi has crafted for the last 10 years in academia, how you can identify liver health and how you can test for it and know exactly where you're at.
Yeah, thank you, Micah. Can you see the screen sharing I'm doing here with the slideshow?
We can.
Yes.
So we're going to use this to keep track of, we want to speed through this. We spent about a week and a half ago, we spent a lot of time going through neurological health, all the different metabolites that are associated there, and some very similar to what we're going to be doing today with just a different organ. I think Micah did a phenomenal introduction on why the liver is important and some of the amazing things that it does. And as we talked to a lot of healthcare practitioners and a lot of our customers of the product, this is one of the first things that they wanted to know about was liver health. Talk me through it. How does your test work? How does the Aristotle identify metabolic patterns, pathways, and how does it how does it tell me how well my liver is functioning? So there's a little bit of background stuff that if you want to get some more information on this stuff, you can go to the neurological health metabolite podcast that we did, our webinar we did. It's available on our website, therio.me. So you can get a lot of that background stuff about the Aristotle, how a GCMS works, and going through all the 126 metabolites that we currently are testing for. So we're not going to go spend a lot of time going through that. I'm going to allow Dr. Moore and Dr. Jasbi to start talking about digital twins and how they're using it to affect your liver health. So let's get started on there, boys. Gentlemen, thank you.
Thanks so much, Matt. So, Alex, you want to start with a little bit of background on digital twins very quickly?
Absolutely. So normally in healthcare, when we're comparing data, say that we do a blood panel, we're collecting various health metrics, et cetera, we're comparing it to population norms. And when we talk about really getting precise interventions, really improving someone's health, that's not super focused, it's not super personalized to that individual. So the idea of digital twins is really kind of forming yourself, your physiology, your metabolism in silico, basically a digital form of yourself. We leverage this particular technology to give very specific health recommendations and also inform our health metric scores, like what Matt was just talking about with the liver score, for instance, on a scale from 1 to 10. That score, when you get our test, is actually based on what is optimal for you. So 10 is not the 10, my 10 would not be the same as Dr. Jasbi's 10, for instance. Right. So this creates a very, very powerful tool because in essence, and as you can see on this slide, is we can form very precise health trajectories for a person. So we can get them to the most optimal health the fastest, being very targeted with our recommendations.
Exactly. So simply put, is a mathematical abstraction of a person's complete profile. In this case, it'll be the metabolomic profile as well as various biopsychosocial factors that we collect relevant metadata on with our HIPAA compliant health survey. In the future, it'll include the ILIA parameters from our upcoming gut health test. And we create a digital replica of our customer and essentially simulate up to 1,000 times various iterations of interventions, medications, supplements, dietary adjustments, and lifestyle changes with their known effect sizes in the literature in order to craft a health trajectory that is the most beneficial and gives our customer the greatest return on their time investment, their dollars spent on procuring those interventions, as well as the opportunity cost of adhering to other protocols in the meantime.
Exactly. Yeah, I love that. That's amazing. So let's walk into liver health then. What do you guys got for us?
Right. So the liver is obviously an incredibly important organ. And really, in the context of our Aristotle test, it's our second most important domain right after cardiovascular health. And why is it important? Well, it's crucial for metabolism, absolutely crucial for metabolism. It's crucial for the detoxification of various processes in the body. It neutralizes and eliminates toxins. It's responsible for producing crucial proteins, essential protein synthesis, as well as regulating hormones, hormone balance, affecting things like mood and sleep-wake cycles, and of course, bioproduction, which is similar to detoxification, but really necessary, not just for detoxification, trapping toxins and excretion via the feces, but also the digestion of fats, fat-soluble vitamins and minerals. It aids in absorption. And so with a healthy liver, we get healthy guts and healthy absorption, nutritional statuses as well. With a liver illness, we'll get poor absorption, poor protein synthesis, poor central metabolism, poor ability to detoxify. And so that's, I mean, we all know the importance of the liver, and in many historical contexts, eating raw liver has been a nutraceutical, has been a functional food that physicians used to give, for instance, for pernicious anemia. The cure was, before we understood the cause, the cure was eating a pound of raw beef liver a day. So liver is an incredibly important organ, and we can go on to the next slide and talk about what we can do and assessing liver health. It's really important when we're assessing liver health to talk about preventive medicine. Regular, liver monitoring functions can unveil abnormalities that can be early signs of various diseases that we'll talk about briefly in the ensuing slides. We have reduced healthcare burden. The liver is considered to be, one of the primary mechanisms for various disorders. It has links to cancers, Alzheimer's disease, depression, anemia.
That was one thing I was very interested in understanding from you guys. Is I've heard a lot of connections between the idea of glucose being utilized in the body and the function it has with the liver, and a proper functioning liver stops the creation of certain cancer cells. Can you give me some examples of that, or just educate me a little bit on that?
Yeah, so really, there's a lot of things that are important in the liver, not just the glucose metabolism, and its ability to phosphorylate things. For instance, we have, alanine. Alanine is linked to the alanine cycle and the generation of pyruvate. And from pyruvate, we can create new glucose. The liver is actually involved in the metabolism of glucose both ways, both in the oxidative phosphorylation of glucose, as well as the creation of new glucose from smaller subunits, such as, pyruvate, like I mentioned. And so understanding the liver gives us a very good understanding of glycogen homeostasis, glucose metabolism, gluconeogenesis. Alex, you want to add to that?
Yeah, the liver is very interesting because we kind of failed to mention on the previous slide, it's actually a very large storage organ within our body. Now, you may think that, well, glucose, I know my muscles, for instance, store a lot of glucose in the form, or carbohydrate in the form of glycogen. Well, your liver actually does as well. And it's actually a little bit more important because it's kind of the dispensary mechanism that we have inside of our body to regulate blood glucose. So at any moment in time in our bloodstream, we only have about a teaspoon of sugar, glucose circulating. So we constantly need to re-up, so to speak, on our glucose level. And there's about 100 grams in the liver. So you can see how the liver can actually get very overburdened very, very quickly, because if you look at a Western diet, for instance, or a higher carbohydrate diet, people are eating hundreds of grams of carbs per day. If they're not active, they're not physically active, they're not recycling through that fuel substrate, they're storing. Okay. And the liver is very, very good at also building basically fat molecules. Okay. It's very good at storing them in the body. It's very good at packaging them up and sending them to other places in the body. So it's critical for fat storage. When you start overloading the liver and you don't have good regulation with glucose, you're going to store fat. You're going to start interrupting in its normal functioning, and it's critical to combating oxidative stress. Critical, and of course we know with oxidative stress that's heavily correlated with cancer status and combating cancer. So we want to keep the liver as healthy as we possibly can so it can continue to do its job with detoxification and combating oxidative stress, particularly with a lot of the really important enzymes that we know, like glutathione, for instance.
Absolutely. We're going to talk about that in some detail coming up,
So we're gonna
especially
be
the
able
liver
to-
enzymes.
So what I just heard then is we're going to be able to draw a very clear connection between insulin resistance, sugar consumption, creation of fatty cells, and your increased risk of cancer. That's what I just heard.
Sure. Yeah, that's very much a possibility. I mean, it depends on the data and the customer's profile, but that is very much a plausible route and what our panel of metabolites can infer to.
And I would say, you know, we see how much of this is connected. We were talking about glutathione. We were talking about glucose metabolism. We're talking about the liver. You don't get a really good sense of the interconnectedness of all these metabolites and your own physiology, your own metabolism by doing a normal blood panel and only getting a few metrics, basically.
Yeah, and let's go on to that, because that's a really great topic. So, you know, very important. What are some you know, issues with the liver? You have fatty liver disease, both non-alcoholic and alcoholic, cirrhosis, which is extensive scarring of the tissue, hepatitis, which is usually caused by viral infection and inflammation. It can, both cirrhosis and hepatitis, if left untreated, can lead to, of course, liver cancer, which is a very serious and fast-moving form of cancer. And given the ubiquitous nature and the foundational nature of the liver in total, you know, physiological functioning of humans, a person's health status can become quickly compromised with an ailing liver. So what are some things that are impacted by it? Not just the liver, but the digestive system, the hematological system. Keep in mind that the liver is responsible for synthesizing heme, which is an important component of hemoglobin for oxygen transport, as well as clotting factors are produced in the liver. The endocrine system, hormone balance, which was something we talked about a little bit earlier, is tightly regulated by liver function. Immune system, various proteins and metabolites produced or consumed by the liver are very much responsible for immune modulation. And of course, central nervous system. We talk about hepatic encephalopathy and the toxic effects of essentially the liver's inability to detoxify urea, which can cause accumulation of certain compounds in the brain and causing, you know, fatigue, slurred speech, blurred vision, etc.
It's amazing to me that just from one drop of blood and using your product and using the GCMS that you're able to see signatures and hints of all these different diseases. It's pretty miraculous, man. This is really great.
Yeah, I think it's a big sort of wake up call for people who are not in science and medicine, but being able to extract 126 metabolites from 20 microliters of blood, which is essentially the dry blood spot sample. That's old news in science and medicine. To us, it's very much sort of business as usual. And we can detail exactly what about our platform, what about GCMS analysis enables us to get down to the past, even below the micromolar level, which is where these concentrations often are in the human body, but to the picomolar and even femtomolar level on certain analytes, given our technique and given the platform we use and various components of that device and how they enable such a, an amazing ability to do that. We might get to that, but for now, let's go on to, I don't remember what the next slide is.
I have a quick question too. Do we know offhand just the percentage of people that have some sort of dysfunctional liver, in the sense that maybe it's not to the point of fatty liver disease, but that it's not operating in the way that it should be?
I can't give those statistics offhand, Micah, but I can tell you that there is a significant portion of the population that actually does have what we call non-alcoholic fatty liver disease, which is basically what I was talking about previously with depositing fat in the liver, which, as I was mentioning, can interrupt so many of the vital functions of the liver. I don't want to give a really hard and fast number, but anywhere from 15 to 30% of the population might be experiencing that in the West.
And it's far more prevalent in the West. It's far more prevalent in industrialized nations with processed food, with, steady food supplies, high fat, high carb foods. It's very much prevalent, much more prevalent here in the West than, in, let's say, the Bushmen of North Africa.
I think also the issue is
it basically following the trend of diabetes? Would you say that they're very correlated?
They are correlated. And unfortunately, there's not a lot of diagnosis. So the numbers that we have based on epidemiology statistics may not be accurate because it's just simply not being commonly diagnosed. Because generally you're going to need some more expensive, if you're going through the traditional Byzantine type medical organization, you're going to have to get some very complex imaging done, usually through MRI, their form of blood test. But yeah, Matt, that's a great point. There is certainly a pretty strong correlation with
it's fascinating to me that people still, like the common person, doesn't realize that obesity can be directly correlated to your liver is over functioning, and the sugar's got to go somewhere. And people think, oh, when you eat fat, it turns into fat in your body. Or when you eat sugar, you just burn those calories. And that can be true unless you're getting excessive amounts of sugar, which is unfortunately, I mean, you see all those videos where they pour Coca-Cola, the amount of sugar in a Coca-Cola, and it's like, it's obscene. It's more than what your liver can process. And so it's got to go somewhere. So I think this is great to get information out, even though it sounds very rudimentary to you gentlemen, or repetitive, because you probably had this conversation so many times. This is what people are here for. This is some of the things that they want to know. How can I test for it? How can I know if, I think fatty liver disease is a spectrum, right? There's a bifurcation, and then there's a spectrum on both sides of it. I mean, you can have a decent diet, but still have fatty liver disease because you're still making those mistakes. People might say, oh, it's just one Coke a day. Well, for some people, that might be way too much, right? And so
some people.
Yeah, for some people, exactly.
Yeah, it's actually interesting. They're trying to change the nomenclature because in medicine, they call it, as I said, non-alcoholic fatty liver disease, but they're actually trying to change it to metabolic dysfunction or metabolic disease associated fatty liver.
And everything is a metabolic disease. Everything is metabolic syndrome. Alzheimer's is a metabolic disease. Cancer is a metabolic disease. And this is the paradigm shift that's happening, or I should say happened in academia. We are realizing that all of these things that kill us the most pervasively and the greatest contributors to human morbidity and mortality are metabolic syndromes. They're not related to the genetics exclusively or even mostly. And there are telltale signs, early indicators in the blood, which is systemic, that we can investigate and infer to these levels, Matt.
And how does that understanding that things are a metabolic disease actually change people's approach to how they're working with the disease or how they're doing preventative measures? Like, how does understanding, liver dysfunction is actually a metabolic problem, or Alzheimer's is actually a metabolic problem, how does that actually change the approach of what people are going to do? Why is that a good thing?
So go ahead.
Well, I was just going to say, it really, I think in a lot of ways empowers the individual, because now we can take some what we would consider basic approaches, but approaches that really move the needle, those more on the preventative side through diet, physical activity, specific dietary components, perhaps dietary supplementation if that's warranted. Whereas before, kind of shrouding these issues in mystery, you're kind of at the mercy of the healthcare system and often, prescription medicines, which aren't, those obviously are indicated in certain instances, but
Sure.
We know when we get a more global view of, metabolism or the metabolism of these certain organs, we can really give these hard-hitting interventions, which seem simple, right? I mean, for some people, it may be as simple, and sometimes they don't want to hear it. Like, look, you need to cut back on your energy intake by 500 calories, and you need to decrease your carbohydrate intake by 150 grams. Well, that's too simple. Well, that's what we found in your panel, and that's what's really going to help this particular score or your liver in this instance.
Yeah, and it's changed our approach, with the best equipped doctors working in the best equipped health systems. They are taking an approach to metabolism by analyzing metabolites and sort of adopting the field of metabolomics, but also the concomitant advances in data analysis that are necessary to analyze this data. We don't analyze metabolomics data, by itself in a univariate fashion. We map this to the global functioning of human physiology, and we're able to take a bird's eye view, and we sort of are able to look at the forests and then zoom into the trees as well. We can zoom into the leaves. We can zoom into the various veins of the leaves, even, to use that analogy. We're able to do that with our data analysis and our very large data collection platform. And when we get to discussing in a little bit the traditional liver function tests and their shortcomings, I think it'll be made very clear how we're much more ampliative to current approaches.
Let's move forward then.
So this is how you know if you have some issues, right? If you have jaundice, it's usually an accumulation of bilirubin. Fatigue and weakness is usually some effect of mitochondria metabolism affected by liver health. Abdominal pain and swelling, pale stool or dark urine is of course an indication of digestive changes that are happening because of the liver's ability to produce bile or lack thereof. Unexpected weight loss. This can be due to, loss of appetite, which is more of a progressive form of liver disease. People who have very high forms of liver disease, very advanced stages, will have loss of appetite, unexplained weight loss, and then itchy skin. And this is because of bile is accumulating in the skin. And so persistent itchy skin in various areas may be an early warning sign of liver health. So if you experience these are the early signs. And then when we go to symptoms of progression, we have, easy bruising. This is because of the liver's role in forming blood clots. So when that is compromised, you're going to have increased bruising with even slight injury, swelling in the legs and ankles, so sort of edema. And that's because of the liver's failure to detoxify. And then, of course, this hepatic encephalopathy, which causes confusion, drowsiness, slurred speech. And again, that's because of the liver's inability to detoxify ammonia to produce urea for excretion. And so those chemicals will build up in the brain and cause neurological disturbances when we see sort of middle to advanced symptoms of liver disease.
So taking this into account, when you talk about the gradients of pathologies, even when we look at early warning signs, right? Jaundice, fatigue, and weakness, everyone's tired in the morning. Everyone, every now and again, has itchy skin, right? But I think the important thing that Alex mentioned earlier is that our test, the Therium Aristotle test, is designed about optimal for each person, right? You should never even have any of the early warning signs, because that's telling you that you're already having significant problems with your liver function. The fact that you're starting to get pale stool or abdominal swelling, like, to me, if I'm trying to act as an optimal, I want my body to be optimal, that's already like, not that it's too late, but it's like, I should have known even earlier than this, right?
Sure.
So how do I find the most early stages, the earliest prevention, being able to identify the function of my liver? That's where I feel like the Aristotle test comes into play here for me personally, and making sure that I can catch it even in stage 1 of it not acting properly.
Absolutely. Yes. Routine monitoring, follow-up, that feedback loop that feeds into our data system and continuously informs our digital twinning recommendations, as well as your health profile is continuously being updated. That is the most excellent way to routinely monitor and preemptively address probable issues as they arise.
Yeah. Go ahead. Micah, you had a question?
I can't recall what it was. Continue on.
Oh, thank you. All right, here we go. All right, here we go. This is the fun stuff. This gets real for all the physicians on the call. Here's your information here.
Yeah, so these are the tests, and I have some notes pulled up here because the computer in front of me is a little bit too small for me to read. But here's some tests that we have normally. For instance, enzymes like ALT, AST, ALP, alanine transferase, aspartate transferase, and alkaline phosphatase enzymes. These are, looking at liver inflammation and damage. Protein levels are looking at the ability of the liver to digest proteins, looking at protein turnover, looking at urea generation. Bilirubin can be, a measure of poor liver health, but it's usually manifested as jaundice before somebody goes in for a liver function test. Clotting times, looking at prothrombin time over the international normalized ratio time. This is giving so again, the liver is responsible for blood clotting. By looking at the time to form a clot, physicians can do this functional test to assess its ability to do so, and can gauge the liver's ability to produce clotting factors. There's also GGT, gamma glutamyl transferase, and lactate dehydrogenase, looking at liver disease and potential tissue damage. And you have platelet count, which is, again, another indicator of the liver's function. And then ammonia levels, again, with very high cases of liver disease, with severe liver disease, these levels will be high. Now, as you can tell, there's 10 different parameters here, really, that, if you deconstruct this, there's 10 parameters that physicians can look at to assess liver health, and these are the traditional health parameters. And soon, as we build out our own ecosystem of testing and we include proteomics in the hierarchy of our testing services, we will be able to assess these as well. However, they are very much irresolute. So if you look at AST, for instance, it's not telling you the levels of alanine or aspartate. It's just telling you the quantity or enzyme activity of those enzymes. If you look at protein levels, it might tell you that protein metabolism is wrong, but it won't pinpoint where that aberration is. It's a very gross measure of protein metabolism. If you look at clotting time, blood clotting, Alex, is, he can go on for this, but is one of the most sophisticated biochemical processes of our body. It involves more than 50 different factors, micronutrients, enzymes, and it is very, it's a gross measure to look at clotting time and prothrombin time, or this, PT-INR ratio. This can tell you that there's something wrong with blood clotting, but it doesn't pinpoint where that error has gone wrong. If you can't do that, you cannot recommend what you should do to fix it. You are stuck with, again, generalized recommendations that may or may not work and require iterative experimentation on the patient or customer. When you look at something like ammonia levels.
If I was going to ask you to summarize this, so what I'm seeing here then is, this is what a traditional physician, these are the types of things and tests that a physician would order to determine whether or not someone has proper liver function. And it sounds like you have a better solution. Or you have a solution that you think touches on a lot of these things to help guide and inform them a little bit faster earlier, right? I think that's the goal here with the Aristotle test is we don't want to be the last test you take. We want to be the first one you take. The first one you take that tells you, okay, you need to go get a platelet count, or you need to go get a protein level count, right? Or a bilirubin, right?
And we often do.
Yeah.
We often do. So yeah, one of our recommendations may be to go get a specific hormone panel. Go test your T3. Go test your T4. We may recommend even colonoscopies. Get your regular colonoscopy. Go get a mammogram. These are recommendations that we give, and those might be in line with what their physicians are already recommending, or they might be a conversation piece to go take to their physician and have a meaningful discussion about what those results mean and what follow-up care for that individual looks like.
Yeah, like for example, like being in healthcare, if I were to end up, if I go to my primary care and he sends me over to go see a nephrologist, well, the nephrologist is very rarely going to go see me internal medicine. They're going to try to, they're there to help me diagnose this very specific specialty, and their tests are informing about their specialty. It's not saying, oh, by the way, you need to go see this guy over here, right? I think that's one of the, as I've seen in healthcare, as it's developed, you get siloed very quickly. And those silos between cardiology, neurology, nephrology, they don't communicate very well to each other when they're in private practice. Now, when you get to Johns Hopkins, Cleveland Clinic, the Mayo Clinic, they do a great job integrating those specialties.
Yes.
For average people that are on this call, or average practitioners that are out there practicing in the world, it's difficult to get a hold of every other test and that people have done, and how they, like, the use of the digital twin is fascinating to me, because you're much more informed about how they interact with one another, these different specialties. So I think it's really fascinating.
Absolutely. So while these can tell you some gross dimensions on which your liver might be ailing, these tests are fundamentally unequipped to tell you where that error is happening and therefore how to fix it.
Absolutely.
You got to know the problem to problem solve.
Exactly.
Yeah.
It's not going to work otherwise.
We're going to dive deep a little bit on the...
Sorry, even before that, Mike, I think look, I don't think there's anybody on this call or anybody that's ever been interested in overall health that would disagree that there are far too many environmental toxins, that would disagree that our food production in the West is not great. If we already know that, to me, it's not then a question of if you will have issues with fatty liver, if you will have issues with glycogen storages that potentially increase your, that's not an if, it's going to happen. What age is it going to happen to you, and at how severe is the problem? So for me, it's about being informed sooner. The earlier I get informed,
your chances of chronic disease are super high, right? Exactly. I don't know what the stats are, but cancer is like what, 1 in 3?
Yeah, and I think that it's
something ridiculous, and that's just one. That might be high, I don't know, but that's just one disease. And so if you're just looking from a statistical standpoint, even if you're relatively healthy, chances of chronic disease are super high, which is part of the problem. And I think we're, testing like this and personalized recommendations, what Dr. Jasbi, that's why I'm here, is because I think it's part of the solution.
Yes, absolutely. I agree with that. All right.
Yeah. So here's a, quick health domain of a score that, one of our customers may receive. As we mentioned, the Aristotle test is, is a multiplexed, multivariate health assessment. And we're able to create various models with various combinations of those 126 metabolites to create validated metabolite sets that can infer to the health of customers based on our training data. And we report across 12 health domains. And today we're only talking about that one slice of that pie. That's liver health. And so let's kind of get into what we do.
That's fascinating to me that we just spent a half hour talking about some like one organ, but it's like, all right, but if our test literally takes 5 minutes to do and you send it out to us, we can give you results of so many different things. There's so much content here to go through, and prioritizing what's the most important to go through is it's a challenge, to say the least. All right, here we go.
So liver is really important for so many things, and we analyze 55 different parameters in the construction of our liver health score. Now, contrast that with like the 10 functional tests that physicians do, right? And what we're looking at mainly is amino acids, urea cycle metabolites, and fatty acids. And there are 30 metabolites in this panel, in addition to 25 liver enzymes whose numbers and activity, whose levels and activity we infer to given bioinformatic analyses performed at the metabolite level. So if you have information on the products and the substrates of these enzymes, you are able to infer to their enrichment. And we create a model that uses these 30 metabolites in conjunction with the inferred enrichments of 25 liver enzymes to then postulate a liver enzymes or liver health score normalized from 1 to 10. We're going to talk about today 3 amino acids, alanine, glycine, and serine, that are critical in in liver health. We'll talk about 2 urea cycle metabolites that gives us an idea of how much if amino acids are talking about protein synthesis, mainly urea cycle metabolites are speaking to the ability of the liver to detoxify. Then fatty acids have to do with, of course, fat metabolism, lipid metabolism, structural integrity of the liver. And we'll talk about 3 of those in the panel: palmitic acid, oleic acid, and linoleic acid. So very quickly, alanine is a non-essential amino acid, plays a crucial role in promoting liver health. It's central to the alanine cycle, which is a process in which these amino acids from tissue travel to the liver and basically support glucose metabolism. And in the liver, alanine is going to be transformed to produce pyruvate, which is a pivotal component in gluconeogenesis and the construction of new glucose molecules. Additionally, alanine is going to aid in the detoxification of the liver by breaking down certain toxins and shuttling byproducts of that toxin breakdown. We also have
give me an example of a toxin, like a really common toxin that without enough alanine, your body's going to struggle removing that toxin.
Oh, here's a good one: glyphosate.
Glyphosate, perfect. Talk to me about that.
Yeah, so glyphosate has various metabolites that, even when broken down, don't necessarily get shuttled out of hepatocytes. And so alanine is crucial for the formation of lysosomes, which are cellular components that go around and sort of eat up cellular debris, which in this case would be the metabolites of glyphosate. And glyphosate is particularly pernicious because it is toxic in its main form, as well as its metabolized byproducts. And so we really need to get those byproducts removed out of the liver cell post-exposure, and not being able to do that will create a very insidious toxic effect to the liver.
So I know this is redundant for probably a lot of people in this call, but I'm going to ask you to spend 30 seconds telling me what is glyphosate.
Roundup. So Roundup is basically something, well, that's the trade name, but glyphosate is highly pervasive. It's a highly pervasive environmental toxin that is used primarily for agriculture. So a lot of our soil has this now. Some agricultural companies are getting away from this, but unfortunately, like a lot of other environmental toxins, like we might talk about PCBs, polychlorinated biphenyls later, but these are just present, and they have a lot of sticking power.
And a very long half-life.
Yeah. Yeah. Very long half-life. Like PCBs, for instance, in your body, it could be in your body for 10 to 15 years. Yeah, but these are highly pervasive, something that's in our food supply.
Water supply.
And it, as much as you do to mitigate this, whether you're filtering your water or perhaps you're even getting well water or whatever, you're being very mindful about the types of produce you're eating or meats. This is still a problem that all of us living in modern day society are going to have to contend with.
So let me just make sure that I can draw the connection. What you're telling me then is that glyphosate, which if anyone hasn't heard of that, there's plenty of information out there about how terrible glyphosate is. It's not only an environmental toxin, and you can see it through that, but you can also see it through the alanine scores in the liver function. So you're actually seeing these environmental toxins in a couple of different areas than through the Aristotle test.
Yeah, we monitor almost 70% of the total human metabolism. The next closest test would be, taking 4 or 5 regular blood tests and getting close to like 19%. We are able to, and then we map that onto, cellular physiology, which is not traditionally done in a blood test scenario. It's sort of just analyzing a univariate level. Your level is here, normal level is this, this means this. Well, that's one thing. But when we talk about systems biology, we talk about emergent properties or the interactions between these metabolites. And the emergent properties are only seen when we look at the interactions between things. When we look at a network, we don't just see the nodes, we want to see the edges connecting them.
Yeah, I mean, I'm glad you mentioned cellular physiology because it is so complex, and you do need these types of approaches that we're utilizing bioinformatically. But I did want to touch on lysosomes, a structure in our cells, because tying this back into cancer a little bit, like if you're talking about autophagy, right, turning on this recycling process inside of our cells, which we know is so critical to not only handling cancer if you have it, but also mitigating its potential presence. You really want to turn on those autophagic mechanisms inside your cells, like the lysosomes and these metabolites that we know are so critical. Can really give us a powerful handle on, do you have these mechanisms at optimal levels occurring in your body?
Exactly. Yeah. So, going on to, glycine is important in numerous functions related to the liver. The synthesis of glutathione, which is, going to be a sort of master antioxidant, quenching reactive oxygen species, important in bile acid conjugation, which is really, essential when we talk about the emulsification of dietary fats, for the digestion of fat-soluble vitamins and the absorption of fat-soluble vitamins, I should say. Detoxification of the liver is really important with glycine. Fat metabolism, it mediates fat deposition onto the liver and is a incredibly powerful moderating variable for the level of fat deposition and is tightly correlated with degree of fatty liver severity. It also has anti-inflammatory effects, as we've seen with inflammation and markers of sustained prolonged inflammation. Collagen formation, it's critical for the formation of collagen and the structure of hepatocytes, liver cells. When we talk about function in physiology, in anatomy, function follows form. And when form or the actual structure, the integrity of a cell or a tissue or an organ is compromised, so is its function. And so when we talk about, collagen formation or the importance of fatty acids, as we get to in the ensuing slides, it is to maintain the integrity of the actual structure of the liver and its cells. Hemoglobin synthesis is really important. Glycine is a prerequisite, is a precursor for the synthesis of heme, which I mentioned again is an aspect of hemoglobin responsible for oxygen transport. Serine is really important. It's important for the
I want to stop you just on glycine just for a second. So
sure.
What I heard you said something about has the ability, something is like the synthesis of glutathione. Can you walk me through like a little bit deeper of what you actually mean by that? What's going on there?
So when we talk about, the synthesis of glutathione, one of the enzymes that creates the final step of glutathione synthesis is glutathione synthetase. And it requires a chemical donation from glycine and other substrates in order to create glutathione. So it is a precursor for that reaction. You cannot make glutathione via glutathione synthetase without the presence of glycine.
So if I'm at a shake shop, a nutritional shake shop, and I say, hey, add some glutathione in there. If my glycine levels are low, am I processing that glutathione?
So you're processing formed glutathione. When we look at glycine, and you're not even absorbing as much as you think, by the way, because taking whole glutathione is not, intravenous is one thing, but when you're absorbing it, in your in your alimentary tract, it's a totally different game. But you're taking the formed glutathione. Now, what makes that glutathione is an enzyme and various substrates, one of which is glycine. So if you're low in glycine, chances are your glutathione levels are also low. Right. Chances are your ability to synthesize glutathione is highly compromised.
Yeah, and so it doesn't. So, and what you just told me is that my root problem is like, oh, I can keep putting 5 or 10 milligrams in there in my shake, but if I fix my glycine issue, that actually might be substantially more beneficial to me than just adding it as an additional supplement.
Absolutely.
I get money from I think those things are like $50 or $60 for each little container that I buy.
Absolutely. Yeah. Yeah. And a lot of that stuff is not being absorbed.
Yeah. Okay.
And then when we look at serine, it's essential for, the synthesis of phospholipids, again, going back to the cellular membrane of hepatocytes, specifically phosphatidylserine, which is a form of serine that is crucial for the integrity of those cells. Again, serine is a regulator of glycogenesis and gluconeogenesis, impacting the rate at which your liver is depositing fats and carbohydrates. It is important for the creation of cysteine and taurine. Cysteine is really important for detoxification, and taurine is important for bile acid conjugation. It's important in 1-carbon metabolism, which is really necessary for DNA methylation and expression of DNA. So serine levels can actually affect how your hepatocytes express their nuclear DNA. It is a modulator of DNA expression in those hepatocytes. So in every cell, you have a complete copy of DNA, but they're sort of specialized to express certain portions of that DNA as a hepatocyte, as a neuron, as an osteoblast, etc. And serine levels in the liver variably affect the rates and expression levels of DNA in hepatocytes. So it can change how your liver is even programming itself. It's really important also in the synthesis of glutathione, just like glycine. It's one of those cofactors for the synthesis of glutathione and the regeneration of glutathione. And then neurotransmitter synthesis. It's, when we talk about, the gut-brain axis, it's really the gut-brain-liver axis. And serine is a precursor for both dopamine and serotonin. And so looking at liver health.
Funny that you're saying that, because I think it's just now, I think if everyone's known the gut-brain connection has been, it's becoming over the last probably 5 to 10 years much more pervasive, that more and more people are understanding it. You just threw a curveball at most people that I don't think they would ever connect the liver and say, oh, okay, got it. It's part of that cycle. Let's talk about it. I don't think that's a very common thing that people like me would understand.
Science moves fast.
Yeah, I think that we actually published on this.
We did.
The liver is, in many ways, when you talk about it, like when you hear all these different axes, like the gut-brain axis, or now there's others out there, the gut-muscle axis is a new popular one. The axis organ in your body really you can kind of think of as the liver. And when you get, for instance, signals from the gut microbiome that are coming into your body, whether they're detrimental or perhaps beneficial, in many ways, the liver amplifies those signals and, as Paniz was saying, connects a lot of this to these systems. So it's absolutely vital.
Wow.
Yeah. So urea cycle metabolites, and here you see the spectra from our GCMS and how we detect them, as well as the superimposed chemical structure for ornithine and citrulline. And ornithine is involved in various things. It's a critical player in the urea cycle, and is one good gauge of how well your body is detoxifying ammonia and producing urea. It is important in cell proliferation and repair mechanisms. It is a main player in the liver's ability to repair DNA, repair its structure, and assess any sort of injury or metabolic challenge. Polyamine synthesis is essential for cellular growth and repair and division. So ornithine is a major determinant of liver cells' ability to proliferate and proliferate correctly. And of course, energy metabolism. Ornithine is going to be essential in the formation of glutamate. And glutamate plugs in directly to the TCA cycle. So a lot of times when we see issues with fatigue, persistent fatigue, or malaise, we will look at specific ornithine production via glutamate and plugging into alpha-ketoglutarate. And then you have citrulline, which is also involved in ammonia detoxification, just like ornithine. It's going to act as the carrier actually for internal ammonia metabolism. And it's really important for nitric oxide production. It does that via a precursor to arginine. And then immune system support. It's essential for signaling to the immune system various issues within the liver that sort of connect the immune system with the liver, are very important for immune health responses. And antioxidants, because it is a contributor to the production of arginine. It influences the synthesis of other molecules like glutathione. Arginine is related to glutathione. And so as you see, we have not just picked out one or two, metabolites that are surrounding like glutathione synthesis, which is a very important function of the liver, or urea cycle metabolism, detoxification of ammonia. We have coverage across the entire metabolomic pathway. So in that entire metabolic pathway, we have various points of analysis, which when viewed together in a multivariate fashion tells us not just that there's an issue, but where is that issue arising? What is the probable cause of it, which then informs our digital twinning recommendations.
So I think that's great. I'm looking at the field of view that you guys have. Like if you don't see them come in, if they come in this door and they don't exit this door, they're still in the room somewhere.
Exactly.
In this room.
It's like looking at a traffic jam, right? If you can see, all the cars on the street, you can infer where the buildings are because it's where the cars aren't, or where there's traffic,
Yes.
you can, where's the flow going? And we actually have a technique for that. It's called metabolic flux analysis. And and we do some forms of that when we map, flux equations to various cell types.
So I'm going to stop you again. And I see another thing that I'm a supplement that I take. I take a nitric oxide supplement. I think it's not too expensive. It's like $35 or $40. I got it at the last biohacking conference I was at. Walk me through that. And so I'm taking this supplement. I just need to hack my body and get the citrulline a little bit higher, or what's the deal there?
Well, with a lot of those supplements, you're not being informed on like what exactly your body would need to actually increase that. Do you know the ingredients offhand, Matt?
No idea. It just says nitric oxide on the outside of the bottle. I probably should know. I should know,
Yeah, you should. I'll let Alex.
So, dig into that, Alex. Yeah.
He's a PhD RD, so he's more qualified.
Yeah, I have a little bit of experience in the realm of dietary supplements, and I know, one of the most, popular type of amino acids that's present in a lot of these products is arginine. But just taking, a lot of arginine, how is your body going to handle that, right? It really comes down to what is needed for you. Now, other people actually, particularly in the exercise world or competitive sports, will use another type of basically vasodilator, because really when you're talking about nitric oxide precursors or nitric oxide type supplements, you're talking about, we want this vasodilatory response. We, for performance, we might get more blood flow, which is bringing in more nutrients, more oxygen, et cetera. For performance in the bed, it's a different kind of a thing. And that's actually what's going to bring me to the popularity of actually using like Cialis, for instance, as a performance enhancement, because in many ways, I'm not advocating this, but it's a lot more effective at increasing a vasodilatory response in our circulatory system than taking a lot of these products. Again, not advocating that, but when we get a kind of a fingerprint of what your metabolism, where you're at, and we look at these specific amino acids, we can give you a much more specific recommendation. And maybe you do need that arginine, Matt, or maybe you don't, and you save the money.
Sure.
Exactly. Would you guys just personally, would you take a supplement without having, like, just on the virtues of the supplement, without knowing exactly what your body needs necessarily or is asking for? Would you, just take a supplement just knowing that it's going to be good?
Well, if I was going to do, I am not, by the way.
I should say thinking it's going to be good.
Sure. If I was going to be, for instance, a vegetarian, there are certain nutrients that I would require. I wouldn't need a blood test to know that. For instance, vitamin B12, I would need
B12 for sure.
vitamin B12 because I'm not getting in vitamin B12 from the sources that it is present in with animal
Choline.
choline. Yeah.
Choline's another.
Also, for instance, a lot of the important essential fatty acids, most commonly or colloquially, we know omega-3s. Definitely those are very, very important, but your body is also very good at sequestering nutrients. Oftentimes we think about fat soluble vitamins, which would be A, D, E, and K. Okay. Having some storage ability in your body. So most people think that water soluble vitamins don't. It's actually not true, because going back to your liver can actually store vitamin B12 for 3 to 5 years. So that's where, a vegan, for instance, they might feel really good initially on the diet, and it may not be a product of the diet itself. It may be related to, okay, they're reducing their energy intake, et cetera. And then a few years down the line, they feel really bad because now they've depleted their body's kind of essential nutrients and they have nothing to draw from.
Yeah.
Wow. Yeah, I that is a very common thing where I hear about people going vegetarian or vegan and they feel amazing for this period of time. And then there's this cliff that starts to happen somewhere. And I don't know if these people that I've talked to were supplementing with B12 or not, but that would be interesting to know. Man, I would love to see some of those people and ask some of those questions, actually, to find out if maybe that was the issue, why they started feeling not so great after, a duration of time, because they're in it. Once you're vegan or vegetarian for 6 months, you get rid of probably a lot of the toxins that your body carries when you eat a lot of this, processed food. But I thought it was that after just a couple of days, you start to feel the benefits of that food. What you're telling me now is that you don't know for months whether or
years.
Years.
It's usually 4.5 years. Your body will start depleting the B12 levels. Yeah.
So if I change my diet completely today, a month from now, I still don't really know if the diet that I change it to is actual optimal diet or not. I don't have any idea.
You don't have an idea if you're not getting this type of profiling.
Exactly.
Yeah. Wow. Yeah. It's good to know. Oh, wow. Okay.
Yeah.
It's amazing.
So, going on to our last class of metabolites, the fatty acids. These are mostly involved, and again, you'll see the spectra and the chemical compositions of them, and you can see small differences in their chemical structure. For instance, oleic has one double carbon bond. Linoleic acid is polysaturated, 2 double carbon bonds. And palmitic acid is really important again for this. These are all structurally important for the integrity of the liver cell. Again, function follows form, and when form is compromised, as is function. In addition to that, palmitic acid is good for a certain level. Too much is one of the primary risk factors and biomarkers for non-alcoholic fatty liver disease, hepatic steatosis. Oleic acid is really important. It has anti-inflammatory effects and is protective, actually, in high levels against fatty liver disease. So we see an inverse relationship there with respect to oleic acid. Linoleic acid, it's crucial for maintaining, again, the cellular integrity, but it's really important for the production of arachidonic acid and prostaglandins, and these are really the main players in ensuring cellular fluidity and proper metabolism within that hepatocyte. And so these are our sort of example biomarkers that we're using. Matt, if you want to go to the next slide.
I just asked a question on linoleic acid real quick. I've seen a bunch of people lately talking about linoleic acid, and it's something about seed oils when they're heated up to a beyond a certain temperature that they express more linoleic acid, that it can actually the levels become somewhat toxic to the body. Can you speak to that at all? Is that something that is the actual thing?
Sure. Linoleic acid and its chemical cousin, alpha-linolenic acid, which are both a part of our panel, do come from nuts, flax seeds, seed oils. And when heated up, yes, sure, it can potentiate those levels, potentiate absorption. One of our primary health recommendations is something that we've always, immediately seen and have been a proponent of, is severely limiting the use of seed oils, the use of canola oils for cooking, for instance. These are mostly derived from the diet by just eating, walnuts and pumpkin seeds. You can get your prescribed levels of linoleic acid and alpha linolenic acid. And cooking in these seed oils is one of the major detriments to modern society that is affecting our health.
Yeah, what you're talking about, Matt, is basically called a smoke point. So, for instance, if I go and turn on my stove and put a pan down and I put a bunch of canola oil and I turn it up as hot as I possibly can, when I start to see smoke rising, you don't want to see that when you're cooking, period. Right. And in fact, another, butter's good to cook with, but actually butter has a very low smoke point,
exactly.
Meaning that it's probably not the best cooking lipid to use. But when we talk about linoleic acid, we also kind of have to talk about omega-3s, right?
Yeah.
Because in the body, and this has been a debate for many decades in academia, like what is better, just getting in a certain amount of omega-3 to omega-6, or is it more about, in absolute terms, or is it more about a ratio? I think kind of both are correct, but in Western society, there's certainly a huge skew with that ratio, meaning that most people are getting way too much omega-6 and not enough omega-3. So what we advocate for, and what you think you're trying to say, is we're basically trying to show balance, right?
Moderation.
Moderation, but also balance for your particular metabolism, because a lot of people that we actually see overconsume omega-3s, which, people think that there's no ceiling to a lot of dietary supplements. People think there's no ceiling. I just need to take more, and it's inert. It's, once if I eat, for instance, salmon or swordfish every single day at every single meal, that's going to be problematic, right? Not only because particularly these larger fish like swordfish or, other large predaceous fish store a lot of toxins themselves, and you're getting that exposure. But also you're talking about a polyunsaturated fat, meaning that it is unstable. It can oxidize. And when you're over consuming a lot of polyunsaturated fats, you have a greater potential for these oxidation type events to occur in your body. And now you have to deal with more oxidative stress.
And you get the formation of these lipid soaps, that's what we call, like arterial plaques. It is from this oxidation of these lipid sources.
There's a question. Bad, not enough is bad. So I'm just out here navigating the world to the best of my abilities. So this is why I need a test like this.
There is a question here. Can you define what you consider oleic acid to be? I don't understand the context of that question either.
Yeah. So anything that is essentially this structure here is oleic acid. It's a fatty acid. It is a monounsaturated fatty acid. What is the context?
Sources.
Sort of sources. Avocados, peanuts. Do you have any other sources for oleic acid? You're the dietitian here.
Yeah, it's pretty common. Actually, you can find it to an extent in things like canola oil. But again, it comes down to a balance with all these fatty acids, and actually all these metabolites, really.
All right, we'll move on to the next slide.
And so this is really how we're looking at a liver score at Therium. As you can see, we've just talked about 8 metabolites, right? I think 8 metabolites, and we have 30 metabolites spread across various algorithmic weights that go into the comprehensive analysis, and each one tells us something about a process or a pathway involved in the liver, that is implicated in the liver. And on this node here, this network analysis you see, that is a real data analysis, very sort of elite analytical technique we use, known as enzyme enrichment analysis. And here you can see the liver enzymes that we are able to cover. There's 25 of them listed here. And so we take our measured levels of 30 metabolites in conjunction with enrichment scores from these 25 liver enzymes. And keep in mind, with traditional tests, you might be getting the functions of 3 or 4 different liver enzymes. We are looking at 25 of them in concert by inferring their levels in activity, more importantly, their activity, given their metabolite levels downstream. And using those levels of the metabolites themselves, we are able to give an incredibly detailed and nuanced assessment of liver health.
And this is why I'm
So
so
this
thankful
is,
for doing what you guys
yeah,
are doing. I just need a score. I need a number and be told what to do. This is a lot. It's a lot. Go ahead, Micah. Sorry.
oh, I was just going to say, so this is a part of so you guys are essentially doing a test. You're mapping out people's metabolism, how their body is working. And you guys as scientists are coming up with an analysis that looks like this. And then you're distilling that into what? Like, what does the consumer end up seeing?
The consumer sees, first of all, a score from 1 through 10. And then in the personalized health recommendations portion, right, here it's a 5, it's neutral, right? And then the personalized health recommendation portion, which is informed by our digital twinning platform, they will get a personalized list of very customized, tailored interventions that they can apply to alleviate whatever the condition that we saw in the liver, whether it's fatty liver, whether it's mercury toxicity, whatever the issue is. We have sort of even within this health domain, that's 1 through 10, there are various signatures contained in that liver health domain. The 1 through 10 scale is a simplification for the ease of understanding of our customers, and the ease of understanding is one of the main reasons. This bottleneck is one of the main reasons that translational throughput in science has been so hard. It's hard to distill this information. It's hard to convey this information. And when we talk about systems biology, your physician, traditional health assessments are looking at, let's say, one kinase right here, right? And in isolation. But what we see here, the connections, right, between these different nodes, which represent the enzymes, are the metabolites involved. Those 30 metabolites are all involved in these 25 different liver enzymes in various ways. And so those connections are, this is what we call the emergent properties. These are the connections that are not seen with traditional health assessments.
Yeah. And Brooke did ask a question. So a lot of people are, when you're doing the chat, you're just sending it to me, the host, so I can see it, but other people can't. So if you mark it as everybody can see the questions and what you guys are commenting. But Brooke, and she said you kind of just answered it now, but I think it's a good question. If after taking your test, you recommend getting more blood work through my doctor, what is the benefit of taking this test versus just going to get annual blood work? And as I understand that is primarily a misunderstanding. I don't think you generally recommend more blood work, but can you answer that maybe?
Yeah, we don't generally recommend more blood work. Everything that, a physician can pretty much look at, so can we. For instance, even the organic acids test and oat is perfectly encapsulated within the Aristotle. There is no other test to take. If you take the Aristotle, you get basically all of the comprehensive metabolic panel. You get various inferences to hormone and enzyme levels, and you get all of the analytes that are in the traditional oat. And so we don't regularly recommend further testing. We might recommend imaging. We might recommend a very specific kind of test for a very specific biomarker or enzyme, but it's not traditionally go get a complete metabolic panel, because, like I said, our test completely obviates the need for many of the traditional diagnostics used.
But it's also important to understand that at current, because we are newer, there's certain things that fall out of our scope. If there's something alarming that needs follow-up with someone's primary physician, they certainly need to be aware of that. Their physician needs to be aware of that. That, again, is rare, but we need to do that in terms of our due diligence in communicating these important health results.
Right. It's very rare, but we do operate on a full disclosure policy. So there are some results that might be striking or sort of psychologically challenging for some people. But we, again, like I said, operate on a full disclosure policy, and we'll recommend even the necessary specialists to see, or the various techniques to do as follow-ups. And that is in the incredibly rare, less than 1% of cases.
Yeah. It's kind of like imaging tech who is like seeing what's happening, and they know that person has a tumor right there, but they're not allowed to say it because they're not the doctor. I mean, you guys, your test is like way better than what the doctors are usually running, but it's kind of like that. But the imaging tech might go, wink, wink, you're going to want to ask about exactly this, because at this point, it doesn't have approval for some of those products. It'll get there, but it's going to take time.
Well, I think to answer that question too, it's a pretty interesting question. I think she's asking, well, why would I take a theriome test if I have to go to my doctor anyways? Well, if you went to your doctor first and said, hey, I want to test, you have to pick of one of these 126 metabolites to have them try to go look at it, and they're going to be looking at enzymes, you're looking at something else. This is a test that you take to say, here's where you need to go look now. There's a problem here, go look here. If you go to your primary care provider and say, hey, I want to test everything, they're going to go, perfect. I need like a quart of blood and I need you to go do all this imaging, and the cost would be exorbitant. He wouldn't, honestly, there would be no medical necessity for them to order all the tests that the theriome test has the ability to look at. Even when you do, like, there's all these ones, the Blueprint and all these Forward Health, all these different companies, they have a certain regimen of tests that they're doing that, as I've understood it, this still encompasses much more of the metabolic cycle and the way that you're processing energy and utilizing energy in your body. So it's just, unfortunately, all the tests that a physician would order, they're complete for that very small section, but they're incomplete when you want to look at the whole thing, right?
Exactly.
The goal for theriome is want to look at you holistically and then say, this is where you're struggling. This health score, right? Whether it be liver health, neurological health, gut health, and say, we need to go focus now a little bit more on this one because this is where we see you're struggling.
It's
And I saw somebody,
eliminating
go ahead.
Oh, go ahead. Sorry.
Oh, I saw somebody ask too, like, I know you guys do a free consult with the test. So like you deliver the report with all this stuff on it, which encapsulates, whatever, 10, 20 tests all into one. And then you guys do a free consult with them with, one of the PhDs on the health and science team. But somebody asked, if I want my doctor to be involved on the consult, can he be involved? So that's a space where the doctor can come in too with the patient, right? And talk with you guys and answer questions and all that kind of stuff.
Absolutely. Yeah. We haven't had a doctor attend a consult with their patient, but they're more than welcome to do so. We have had many instances, though, of a patient connecting us, let's say via email, with their doctor, who has transmitted, let's say, various other testing reports and imaging reports. And we're able to deconstruct even those data points into our algorithm to feed it and give it even more granularity and specificity for that particular customer. So although we've worked sort of in a sort of dispersed manner with physicians regarding specific patients and their health issues, or we have some of our affiliate physicians who order the tests for their patients regularly, they will do the consult for us, with us, and then they'll sort of convey those results to their patients. But having a consult with a patient and their healthcare provider, we welcome that. That's even bridging the gap even more.
Yeah. And I see a question here too. I've always seen that the O as a urine test. Is there a difference in accuracy between yours and a urine O test? And I kind of, before you answer that specifically, I want to kind of describe the big picture of this test. Is like, so you can test a lot of things in the body, right? There's multiple things that go into it. Like, what pathways are you testing and how do those correlate to the pathways? How do they talk to each other? And so you can get an analysis on bio data. What is really valuable that is kind of at this forefront of science is basically the translation and understanding what is happening into the body. So with what Dr. Jasbi has created over the last 10 years, it's essentially, he's roped together this really big body of science, and Dr. Moore, this really big body of science, and pooled that together so that it gives really, really deep translation and understanding of what's happening in the body. And he was able to say, okay, this is the most important pathway for here. This is the most important pathway for here. This is the most, and a lot of these tests are writing on really old mechanisms, really old translation capabilities. And so they're pretty dated. And so Dr. Jasbi has taken, like, he's the first in Dr. Jasbi and Dr. Moore are the first in the world to rope together this big body of data so that you can get the granularity with the high level understanding of what's happening in the body. So comparing it even to the oat test or a test like that is kind of like apples and oranges. Like, yes, we encompass everything that happens in the oat test, but we also encompass 20 other tests. Plus you're getting earlier detection of things. What is it? 98%, 95% of the chronic diseases that kill people were able to, I shouldn't say identify, but you can get an understanding of, you can assess a risk of those, wink, wink, at a much, much earlier stage than what you can get through doing all these tests combined. So like, just to kind of describe it on a high level, and I want people to understand that because I think it's really important to understand, like, this is a different thing. Like, yes, it's an improvement, but it's altogether different. Like the paradigm of current healthcare is going to have to do a lot of adoption to understand, like, what there are huge companies researching just to try to identify what Dr. Jasbi has already done.
What you're talking about, Micah, is interpretation, because your physician, your healthcare provider, you can do all these tests and you can give them pages and pages and pages of data. They have to go through that and interpret it based on their education, based on their experience, which is excellent. I mean, they're obviously they do, by and large, a great service to our society, but that is a huge burden. And when you talk about this amount of data, like this plot that you see on the slide, to most people, it looks like a hairball.
Yeah, we call it hairball sometimes in science. Yeah.
So what we're basically providing is that interpretation based on the algorithms, our bioinformatic tools that we've developed in-house to provide that reliably and also efficiently, meaning that, we're not a tired, doctor that I've been up for 16 hours, 18 hours. I'm not feeling too good. I may not do the best job interpreting these results and giving you the best recommendation, where our algorithm never sleeps, right?
Algorithms don't sleep, and I have a Mayo Clinic physician, and to even get a time with this guy is 18 months out. And he doesn't even read the patient survey data that I fill out before I meet with him. Actually, I fill it out on my phone before I meet with him. And I mean, that's just patient survey data. No human brain can keep track of 126 metabolites, their levels, and their meaning in a biological network, as you see here in this analysis. No human brain can, regardless of their training or education. It is impossible. And that's where algorithms come in. More to the point of the question that was asked, Michael, why don't we look at urine? Urine is urine, feces. These are excretory profiles. So we can look at various things, right? If we looked at, tear drops, which we can actually, we would be looking at sort of an aqueous metabolite profile of, eye health. If we were looking at cerebral spinal fluid, which I have in some of my studies, or even neocortical tissue from autopsied brains, which I have in some of my studies, we're looking at central nervous system functioning, right? And when we look at urine or feces, it's an excretory profile. It is inherently an incomplete picture. We have chosen blood because it's a systemic tissue, right? Blood is the systemic tissue. It goes everywhere. It interacts with everything. And it gives us that sort of very attractive level that we can probe and query. And if you've ever heard of, liquid biopsy, this is essentially it. This is what we're doing. It's a liquid biopsy on a dry blood spot.
Yeah. And if I had to...
Go ahead, Mike, keep going.
Oh, if I had to put this in really simple terms of like understanding what you created, I guess I would say it is by a mile the best test out there. That's a broad understanding of what's happening in your body with utmost specificity into what to do about it. So what does that mean? Like, I have these ambiguous symptoms, or doctors haven't been able to diagnose me, or I just want to be healthier. This is the best thing you can do. That's going to give you a really precise direction of where to go and what's happening in your body. I truly believe that this test is, as we progress forward, and it's really cool. People here today, that are learning about it, you're very early on in this. And so it's kind of cool that you're here, because I think you're going to see this become a standard of testing where other people are trying to it is the benchmark. other people will try to bench against it to see like, how do we compare to that test? Not just like business wise, but in terms of data and science and understanding how the body is working. And that's where I really think this is going, is that it's going to be, I think, a standard of like what's happening in the body and what can we do about it. And then, of course, there's more specific testing that you may need to do in the case of like, you need to do imaging, because imaging shows you physically what's happening in the body. But this is like the great compass of the body.
And with that compass, you want to, I mean, it's to your benefit to have a certain cadence of sampling. For instance, this is not like a DNA test where you take it one time and you have your genome profiled. This is something where, you know, depending on your health state, you know, we're not going to recommend a blanket sample cadence of every 6 months. It really depends on the person's health state, but you can get informed if what, you know, we recommend or what you're doing, if with its diet, your medications, even supplementation, if it's actually working. So you can see these levels change over time. You can bring this data, you know, we take the metadata that you bring to us in your surveys, also the biological data, it all feeds back into our algorithm. It actually makes it more powerful. So honestly, the more data we have, the better, the more fine-tuned, not that, you know, our recommendations are really excellent, but we can get even more specific over time with more sample density.
Yeah. It's like, it's kind of like how AI at the beginning, it was the dumbest version of itself, but as it learns and understands, it becomes like, you saw the potential, but it was still like, there's a little gimmicky, not quite working. But that's kind of a similar concept here, is like, as it grows, it's going to get like scary accurate. Like, oh, at 5 years old, you fell off your bike and scraped your knee. Maybe not quite there, but, and I want to share a couple of stories too on the point of what you're saying, Dr. Moore, is like, there was one lady that came in, and, you know, she was pretty healthy, just wanted to be more optimized. And she would take her food and prep every day and, you know, have her macronutrients mapped out. So pretty healthy. But Dr. Jasbi did the consult with her and said, like, based on this testing, it kind of seems like you're getting exposure to microplastics through heating food in plastic containers. And it turns out, and that was without knowing, you know, all the details about what was going on in her life, just through doing the test. He was able to identify, and she's like, yeah, every day I, you know, prep my food. It's in a plastic container. It's nice and compartmentalized and all that. And then I heat it up in the microwave, and he can identify like really granular things like that. Or another one I thought was funny was that one lady, she was just a difficult person, like, just to say it, like, I love everybody, but some people, you know, they have a lot of time. And she took our tests, her and her husband, and then they did the consult with Dr. Moore, and their view of themselves wasn't replicated in the test. So what that means is like, I am very healthy, I am this. And so the test didn't show that, though. It showed some issues here, and here, and it gave personalized recommendations on that. So she was kind of rude and said it was laughable to Dr. Moore, and was like, this is a joke, and asked for a refund. Turns out she followed the recommendations. A week later, we had a testimony from her saying, I feel 1,000 times better after following the recommendations. It was actually right on point with what she was looking for. But anyway, I'm digressing too far. I'll let you guys get back to it.
So Matt, could you go?
That was one thing that I actually wanted to make sure that I said, because sometimes the recommendations seem a little too simple, right? And we use this word metabolism for a lot of people know exactly what it is if you're in the science or medical field. But for people like me that are not a physician or they're not a PhD, a metabolism, it's our bodies need energy to do everything from moving around, thinking, and growing, right? Metabolism is the chemical reaction of the body's cells that change food into energy. So your body needs energy to go do everything from grow new hair to move physically throughout the world. Food is the baseline of what are you getting in and how you're going to absorb and use this stuff. So it's sometimes seen so silly that blueberries or, you know, almonds, it might be a cure recommendation for one of the low metabolites you have, but where else are you going to get a metabolite other than food? That's where it comes from. That's how you consume it, or getting maybe sunlight or, you know, some other ones, for example. But go ahead. What were you asking, Dr. Jasbi?
Oh, I was just going to say, if you go back to one slide. So these are some things that are general recommendations for liver health. If everybody on this call went home and addressed these issues, they would have improved liver health. Now, how much is all of this necessary for everyone? What about the dosage, frequency, duration to observe these interventions? All of these things, if followed properly and adequately, would lead necessarily to an increase in liver health. But I want to present now a case study from one of our customers whose demographic data has been anonymized. Dr. John Doe, he's a retired dentist. And what his primary concern was exposure to mercury during his career. And dentists of his era worked with various devices that had mercury or handling dental amalgams that were exposed and contained mercury. And so, when we test our customers, we normalize it on 1 to 10. 4 to 7 is considered normative. Anything above 7 is optimized. They're doing very good in those domains. And anything below a 4 is considered poor and requires and warrants some sort of further addressing. So this gentleman had 3 poor scores, and they were liver health, environmental toxin exposure index, and mitochondrial health were all low. He presented with very generalized symptoms that I think all of us experience at least 1 or 2 times a week. Those were fatigue, mild cognitive impairment, and occasional tremors, and some difficulty concentrating. So
who doesn't have fatigue?
Who doesn't have those? Right. And really what he wanted was the comprehensiveness of our data collection, the sophistication of our data analysis, as well as the granularity of our digital health recommendations or digital twin recommendations. And
this
so
goes back to Deborah's question earlier. If she walked in at her provider and said, I'm a little tired, I get a headache every now and again, it's hard for me to focus, he's going to go, okay, get more sleep.
Yeah.
Better?
What is he going to exactly? So what are the recommendations going to be? Eat better, get more sleep, right? So let's take a look at what we found. And he presented with, hey, I'm a little concerned because I have these issues. So one thing that we noticed, and again, I'll bring up my iPad because this screen in front of me is too small to read. But one of the things that we noticed sort of immediately from the go was his mercury exposure. He did have markers that were, we hypothesized were due to his reported occupational exposure, but they had accumulated mercury within his system, primarily affecting his liver, his mitochondrial health, and his toxin exposure indices. Also, the liver score presented certain liver dysfunction, mild fatty liver disease, possibly due to his alcohol consumption, which was reported to be every day. And then mitochondrial profile was pretty low too. Various metabolites of the Krebs cycle and oxidative phosphorylation were compromised, those levels. And so we are seeing the downstream sequelae still of that mercury, but it's reflected in the liver, it's reflected in the toxin exposure index, and it's reflected in the mitochondrial health. So what did we do for Dr. Doe? We took his complete metabolic profile. We fed in his Omni survey responses, his biopsychosocial metadata that we also collect self-report information on, and as well as some other things that he had sent over regarding his previous health tests and his health trajectory. One thing we recommended was DMSA, which is a specific type of chelation therapy. And we were able to not just recommend it, but we were able to say, craft a very specific protocol for him to follow. It started with an initial 3-day trial at 10 milligrams per kilograms of body weight every 8 hours. Now, we told him to monitor it with, his supervision of his healthcare provider and continue it for 14 up to, 28 days, 4 weeks after that initial 3-day period, and then do 11 to 14 days based on his own tolerance as a rest period to allow that therapy to essentially the benefits of that therapy to be realized. So that is one thing where we said, listen, chelation therapy, using DMSA, this dimer captosuccinic acid.
Yeah, what is that? Like, what is this, a pill that you would take? Is this a supplement? What is this?
It's a chelating agent. So it essentially binds mercury and prevents it from, exercising its toxic effects at the cellular level, and it can be marked for excretion, readily marked for excretion. So it's a way to think of it as, in this context, as a mercury sponge.
And so this is something that I can just go on Amazon and buy.
This requires still in the United States a prescription. However, with our recommendations and specific dosages, he took to his physician, working closely with his physician, and got the same exact recommendation. And I'm told that his physician was very much impressed with our sort of ramp and our protocol. And again, this is all, you know, given to us via our digital twinning platform. So it's tested, tried and true up to 1,000 times on each individual.
So you basically gave the physician in this scenario then the tool that he needed in order to go, okay, let's order this testing for you and let's get you better. You gave him.
It's traditionally used in lead poisoning,
Right.
but it also works very effectively for mercury and arsenic.
Understood. Okay.
So the next thing we did for Dr. Doe was sort of very bespoke health recommendations for him. Dietary interventions mainly. We told him to consume more garlic, onion, broccoli, cruciferous vegetables. He wasn't observing any sort of ketogenic diet, so we had no sort of dietary constraints. But if a customer reports that on their survey, then our recommendations will shift in order to maintain their dietary preferences, whether it's a vegetarian diet, a carnivore diet. As much as possible, we try to observe and respect, you know, our clients' dietary habits and lifestyle. But he didn't have, he reported a balanced omnivorous diet. And so we're looking for, you know, sulfur-containing vegetables, at least 1 serving per day. And, you know, when you look at the recommendations for what is like kind of required for a generic health detox profile, depending on the detoxification protocol, maybe 4 or 5 servings, in which case he's stuck eating broccoli, onions, and garlic at every meal. Our tests showed that in conjunction of the chelation therapy and everything we recommended downstream of that, 1 serving a day would be sufficient for him. Also, we wanted him, again, if I'm looking at my iPad, I'm sorry, I cannot look at the screen. It is a little bit too small for my eyes. We're looking at integrating various berries, specifically blueberries and strawberries for their natural antioxidant capabilities, walnuts and almonds for their sort of micronutrient content. And we aim for 2 to 3 cups of so 1 serving of berries a day, and then 2 to 3 cups of green tea. And this is, again, very much in line with the experiments that we performed on Dr. Doe's digital twin. You want to go to the next slide? So this is the supplementation. So we wanted to boost his glutathione levels because we saw that was a major issue with this particular person. We advised him to take NAC, which is N-acetylcysteine, which is another important precursor to glutathione. If you can't tell, there's a few at this point. But this is where we saw in his metabolic pathway that there was an aberration. And by introducing NAC, we were able to simulate, well, what dosage does he need? How often does he need it? How long should he sustain this for before retesting? So we're able to say 600 milligrams twice daily. We're able to get very granular with that specification. Also, milk thistle, which is a natural supplement. We looked at his detoxification parameters, specifically looking at metabolites related to glutathione levels and ammonia detoxification. And we recommended milk thistle at a concentration of 150 milligrams, again, twice daily. And that is, one more time, a very specific recommendation that somebody can say, go take milk thistle, go take NAC. Many of our customers who are very much health conscious and ahead of the curve come to us already taking NAC. NAC is one of the most prevalent, supplements that we get when we perform these consults. And sometimes it's needed, sometimes it's not needed. Some people are often over supplementing with it. How much you take and how long you take it for, when you take it even, is really important. We had one customer that was taking magnesium. Unknowingly, it was interfering with her Cytomel, which is a prescription medication for T3 hormone. It's a synthetic T3 hormone. And she wasn't absorbing her medication because the magnesium was interrupting its absorption. So by just looking at that, we were able to say, okay, take them 4 hours apart. So these sorts of things, when it comes to supplementation, sure, milk thistle is great. Glutathione is great. Should you take the precursor? Should you take the actual glutathione? When should you take it? How much should you take it? How long should you take it for? That is where Theriome comes in. So, and then the next thing we asked him to do, he reported regular alcoholic consumption, more than 2 drinks a day. We asked him to, and we can see markers of chronic alcohol consumption as well. So in addition to the concerns about mercury, which were confirmed in his blood sample, we also saw markers of high alcohol consumption. We asked him to reduce that alcohol intake to no more than 2 servings in a single setting and no more than 2 days a week. So maximum of 4 drinks a week total, split across no more than 2 settings. And that recommendation, again, was very specific to his profile, right? We didn't need him to completely cut out alcohol. If he enjoys a glass of wine with dinner and a scotch after, maybe at the end of the week, he should be able to enjoy that, but within sort of limits that the science has said, these are tolerable, these are non-toxic, and these, even making these sorts of adjustments led to a rapid increase in his health scores. So
I think that's where it's important to know what we're trying to accomplish, right? Each individual, as we're setting on our health longevity journey, or just wanting to feel better, or, you know, heal from certain ailments, there's unfortunately always going to be a give and take. And I think this is one of the ones that I continue to hear: alcohol consumption and obviously the liver function. You know, I don't think it's anything new to anyone that excessive intake of alcohol is probably really bad for your liver. But even moderate, what my moderation versus someone else's moderation might be completely different, but the way that it affects us, it is unfortunately different person to person. So it's important to have kind of that baseline level of knowing how it's affecting your body. You know, just because I can have 2 beers and you have 2 beers and we act differently, you could be, from a metabolic standpoint, dramatically different in the way your body's processing it. Because you have other,
and there's a wealth of science and literature to support what doses of alcohol intakes and frequencies are tolerable for certain types of people, right? So how, you know, your metabolic profile is shaped and it's composed, that is going to determine how much you're able to tolerate of various things, one of them being alcohol, right?
Yeah, when I'm saying tolerate too, I'm not even talking about mental toleration. I'm talking about like physical toxin, you know, removal from the body, right? That's a big one.
Sure.
All right.
So the next thing we recommended for Dr. Doe, and Dr. Doe already did 2 to 3 times a week of strength training. He's a pretty well-built man. However, we recommended aerobic activities in conjunction with that. And this is for enhanced circulation, enhanced blood flow, increased rate of detoxification. You can take all those chelating agents as fine. That's great. But if your circulation isn't, you know, optimal as well, that drug isn't going to work as it's intended. And so we recommended 20 to 30 minutes of moderate to vigorous physical activity. And again, that was really for facilitating what the science has shown to be a necessary level to ensure an efficient removal of waste byproducts, whether it's the alcohol or the mercury.
Yep.
So then we recommended sauna and hydration. And he loved this because he had an infrared sauna in his house, which is really great. You didn't have to go anywhere to do this. But we recommended infrared sauna once a week for 20 to 30 minutes. That's really important for the detoxification process and inducing sweating, of course, but infrared saunas in particular can potentially, you know, penetrate the skin even deeper and really aid even more in the detoxification process. And so being able to recommend the type of sauna, the frequency you should observe weekly, as well as, you know, the duration of that is really important, given, well, this is where you're at. If you had more of these sort of byproducts of the observed toxins, it would be more. But we have sort of fine-tuned it to be both practical, actionable, and sustainable. So that's really important for, you know, the recommendations we generate. If they're not practical, actionable, and sustainable, no one's going to do them or do them in the long run. And then what we wanted him to do is, he reported, you know, sort of 8 glasses of water a day, which is far more than so many people take, but to really make sure that he, you know, expels the waste products and the harmful downstream metabolites we saw, what we refer to as anti-metabolites. We recommended that he take at least 3 liters of water a day, maybe some lemon in that for added detoxification. And that's really true, that these are the processes the literature has shown to be the most effective. And some of them can be chelation therapies, which is a medical treatment. And some of them can be water and infrared sauna, which is also proven clinically significant in intervention for these sorts of cases. And so let's look at his follow-up time. We recommended 3 months. Dr. Doe came back to us. His liver and environmental scores doubled, went from a 2 and a 3 to a 6 and a 6, tripled and doubled. And then he actually tripled his mitochondrial score as well. He went from a 3 to a 9. And that's very much in line with what we predict. We do predict what these scores would be if this was sort of 100% compliance for the time duration. And it sort of depends. We have customers who are very fit, healthy. They score very high on all domains. We might recommend a retesting timeline of 18 months. But for a person who's working through, sort of high levels of toxicity and very acute lifestyle changes, and they want to get a more immediate feedback, we recommended 3 months. And lo and behold, he was in the normative range for 2 health domains that were previously poor. And 1 health domain that was previously poor is now highly optimized in Dr. Doe. And that is the case study. That is sort of how do we go from these very generic, vague recommendations that anybody can do right now. Anybody can, on this webinar, go ahead and implement those in their lives, and they'll see some sustained benefit. But which ones are working? Which ones need to be sustained indefinitely? Which ones need to be sustained for 3 months? What are your dosages? Should you take the supplement in the morning or the evening? And those sorts of answers are only done, again, through a very complete data collection and a sophisticated bioinformatics pipeline.
I'm going to interject. Sorry, Matt. I need to interject just for a couple minutes, and then we'll get back to the conversation. But there's 2 things that I promise people. Number 1 is Dr. Jasbi just finished his book. So congratulations, Dr. Jasbi. It's not all designed up and pretty yet, but if you want to get Dr. Jasbi's book about metabolic health and metabolic testing, and what are all the things that we've discussed today, but condensed into a book plus more. If you want to get that for 100% free, this is that free giveaway that I mentioned at the beginning in the chat. Just type book in the chat, and I will send you Dr. Jasbi's book for 100% free. Like I said, it's not 100% designed in the sense of like a nice cover and all that kind of stuff, but all the information is 100% done. And it's just such a solid piece of work. That's also going to tell you about the future vision of this and where it's going and the ramifications it's going to have. So that's the first thing. So if you want to get Dr. Jasbi's book for free, I'll email it to you, but you have to write book into the chat, and then I'll get that emailed off to you after this. The second thing that I wanted to mention is, so I have one of the test kits here, and that's what it looks like. So this is actually, I have a prototype because Dr. Jasbi considers me special, and I appreciate that. So I have a prototype of the box. The box that you guys will get will look a little bit different because it doesn't have the Therion branding on it. We buy it from a company called RDA Spot. And then that's just the kit though. Obviously Dr. Jasbi has his lab in Phoenix and all that kind of stuff. So yours will look a little bit different, but this is the test box. So what comes in it? Well, when you get your package, you open it up, and there's going to be a couple things in there. There's going to be some filter paper. There's going to be some finger pricks. I think those are pretty much the 2 things, but I'm just going to walk you through real quick how to do this test. So you buy the kit. That's the first step. Then you get the kit at your house. You finger prick on the side of your finger, massage it up, shake it if you need, and then drop those pieces of blood onto 2 little circles and make sure you fill out the circles. Then there's a label in the box where you just slap onto it and you ship it off to Dr. Jasbi's laboratory. Takes 2 to 3 weeks for sample processing. Dr. Jasbi's very proud about his sample processing time. So I say 2 to 3 weeks. He says a week. Okay. So I like to set expectations low. So then when I come in and over deliver, it looks better. Right. So, but within a few weeks, you're going to get your report. And once you get your report, you also get a free consult with Dr. Jasbi, Dr. Moore, or Dr. Ortega. And they're going to walk you through everything in your test, tell you about the personalized recommendations, what to do, all that kind of stuff. So that's how the testing thing works. And we actually have a discount for people, but it's only open for 12 hours. So if you want to get the test, jump in on and get the test. I'm going to drop it in the chat here.
Matt, you can go to the next slide, actually. You can rest there, maybe.
Yeah. So, yeah. And then we'll get back into Q&A. So I know I'm just kind of giving the important stuff right now. So if you want to get the test, let me make sure. Yep, that is the right link. So for the next 12 hours, the test is $331 off. So by clicking this link and buying the product, you save $331 off. It's normally $830. We whittled Dr. Jasbi down to $499. So click that link to get the test. It'll get delivered and shipped to you pretty quickly. You take it, you send it back to the lab with the label that's provided in the box, and then they're going to do a free consult with you. And then you improve. Then you know what to take. You know exactly when to take it, how much to take, what interventions to do. And you just follow that protocol. So it makes it very, very easy. And again, it's only open for 12 hours. And that link right there, if you click it, it'll automatically give you the $331 off when you buy. So yeah, that's my bet. I just wanted to share, and we can get back into the discussion, but yeah, just wanted to share that.
I wanted to ask some questions about the book. You know, I had a chance to read it the other day, and it was quite extensive. I think there was like, I mean, there was over 100 just citations, which is great for me to see when I'm reading something. I want to see like, all right, who else are you referencing? Well, how much was it?
It's 150 citations.
150 citations. And
it's
so
not
when
too much.
Generally when you're reading, so like, okay, there's other points of reference that, you know, when people are making a lot of the claims that Ethereum's making in the way that you're doing this, it's great to see that you're basically resting on the shoulders of some really dense, well thought out and well published science, and you're just building upon, you know, what's decades of work from other people, but you're getting more specific. You're getting more. You have the ability to kind of build more infrastructure behind it. That was great to see in that.
Absolutely. We really do stand on the shoulders of giants, if we can borrow Isaac Newton's phrasing. Could you go to the next slide, Matt? We'll rest there. Really, you know, we have looked at and curated a wealth of data that supports the models that we make to assess the health of our customers, as well as the interventions we're recommending using statistical measures that inform us as to the best approach for different customers given their complete metabolic and biopsychosocial profile. And so we really have, you know, built out a wealth of this, and this is really from the far reaches of not just science, but what we call high science, right? There's a difference between, you know, science at different levels, and I'm happy to go into it, but this is high science. And this is when you send in your results on that third floor of this beautiful building in downtown Phoenix at the Wexford Science and Technology, sort of the innovation quarter downtown. That's where our central laboratory is located. That's where we process the samples, intake them, and get them ready for analysis with gas chromatography, mass spectrometry. And so we really have, you know, you have to, when you read that book, appreciate the interdisciplinary nature of systems biology. Everything from engineering to physics to mathematics, computer science, analytical chemistry is used in order to infer to biology. And so it is a incredibly synergistic and interdisciplinary field. And Dr. Moore and myself truly really do stand on the shoulders of giants. And although we have, you know, many papers ourselves in very sort of top tier, very well respected journals, we cannot do this alone. No two scientists can ever do this alone. It really is the culmination of the you know, decades long scaffolded efforts of many scientists in the field, to whom I'm indebted, and much of the acknowledgement of that book is dedicated to.
Great. I have a couple questions here. Unless Matt, you want to chime in with something.
I have some excerpts from the book that I want to close us out with, but let's get through the questions first. Let's get that done.
Okay. Yeah, because these people have been patiently waiting. I told them I'd ask Dr. Jasbi as soon as I can. The first one, are you able to detect the MTHFR gene mutations? Yeah,
for sure. The MTHFR is going to lead into various disruptions in cobalamin and folate metabolism, specifically tetrahydrofolate and the folate trap. And we are able to very keenly look at the effects of MTHFR mutations. That is something that a few of our customers have actually had concerns over, and our test is very well suited to look at.
Next question. When you tested yourself, what was your biggest takeaway and how did you address? So I'll answer first, and then Matt, maybe you have something to chime in with, and maybe even Dr. Jasbi and Dr. Moore. I mean, you've used your own product, and maybe it's given you some insights, but for me, so I've done 2 tests this year alone. So, you know, I'm relatively healthy, but there's a few things I'm looking for. One, I want early detection of like cancer runs in my family. So if I can detect that at stage 1 very early on, outcomes are going to be so much better, like through the roof. And so that's part of why I'm excited about this project, is because it'll save lives, quite literally. And very directly, right? Because if we can get that understanding of what's happening in the body very early on, you can, even if you don't go through all the conventional stuff, which I'm not saying don't do, But I'm just saying, even if you don't go through that, the outcomes improve drastically because there's a psychological change and subsequent lifestyle changes that are made. So that was the first thing I was looking for. And, that was all good. Dr. Jasbi told me my report was relatively boring, which is a good sign, right? The other thing was folic acid. I don't methylate well. So being able to take some folic acid, and I can't remember the exact supplement I take, but the folic acid, so you methylate better, feel better, all that kind of stuff. I have it's not a genetic test, but that is due to a genetic issue. And so I don't methylate as well as you should. And so being able to take that in the past, even before this, I had done some testing and I had heart palpitations. And so going through that process of, I'm a little bit neurotic about health. Not a full hypochondriac, but not too far away either. So, it's concerning when you can physically feel your heart and multiple times a day type thing. And so I was able to go through the testing and make just some very simple lifestyle changes. I know to other people is blatantly obvious, but I was just taking too much in the way of caffeine and stimulants, not sleeping enough and all that kind of stuff. And so it gave me insights into that. And, the thing is like that was stuff I knew mentally, but there's something about seeing it on paper, the objective data that gets you to make the difference. And so there's like a similar concept with exercise that I've used in the past, which is social pressure. Like I know what I need to do as far as exercise, but if I put myself in front of a group or get somebody to hold me accountable or have a partner to work out with, and we show up at this time, I do it, right? And I'm much more likely to do it than I'm on my own. And this is coming from a guy that used to be in the gym all the time, love it, and that kind of thing. It's kind of, the passion has fallen away. And so it's a little bit more of a discipline now. But there's something about just having that accountability. And so even if some of the changes that you need to make, it's very helpful for me. That was just my personal experience with it. So overall, pretty helpful and something I'm going to continue doing probably 3 to 4 times a year. And I don't know if you guys have some experiences you want to share too.
I'd love to share mine. I've had, I think this year I've done 3 or 4. And the thing that I've really enjoyed so far is, sometimes I've taken a test after a week of doing something that I know that I shouldn't have been doing, whether it be, drinking too much or not exercising. Like it's pretty accurate. Like when I take a test, I've known how I felt. I'm like, man, I just don't feel great, but I got to take this. And then I'll see something come back and I go, yeah, I know I forgot to do that. I stopped doing that. It's a reminder that seems so simple to remember, but until you actually have someone show it to you and say, look, this is no joke. Let's pay attention here. It is kind of hard to stay with it. Right. And so the recommendations they've always been helpful to me. Like my most recent one, as you guys kind of heard earlier, I started taking some additional supplements kind of, without Dr. Jasby's approval or recommendation. I just started taking some stuff. And then my aging index came back lower. I'm like, oh, okay, what's going on? What did I do wrong here? Right. And so we're getting in the middle of that stuff. So, the accuracy of it for me has been very interesting to see. The way that I feel is represented on a piece of paper. Whereas I could go get normal tests from a primary care provider or specialist and, oh, you're in your normative range. Well, how come I don't feel like a normative range? I don't feel like your test says that I'm okay, but I don't feel that way.
The average person is sick, right?
Yeah. And that's because they're, again, looking at one parameter. Let's say it's, anion gap, right? They're looking at one thing and they're saying, oh, you're normal. And, there's a wealth of evidence that has validated the Aristotle test. I sent an email to an interested customer who's looking for the validation and sort of the replicability of this test that we have published on this. For most people, that's not the level of evidence they want to see. Most people want to sort of see, okay, I've been living poorly. Let's see what it reflects. Oh, there it is. I've done this. Let's see what it changes. Oh, that's exactly what it is sort of saying, oh, you had a very high, metabolic health association and risk of autism. Oh, this person doesn't have autism, but lo and behold, their youngest daughter is highly autistic, is on the high end of the spectrum, nonverbal, and has developmental delay. And we're seeing that in the mother. And there's various reasons for that, but the colloquial evidence has been the most striking and most convincing. Although we have, peer-reviewed publications to demonstrate its efficacy, that personal evidence that people get has always been the most powerful.
Yeah. And you guys will see that as you take the test more frequently, for those of you either haven't or you've taken one, It's really that second and third one by the time you take that and you've consciously kept track of what you're doing, that you start to go, okay, this isn't, a handful of blueberries isn't a joke. There's some legitimate science behind that. And when you follow it, your body operates more effectively, for sure. What are the questions you have, Micah?
Yep. Well, one real quick here that I can just answer is, how can I set up a practitioner account? Paul, just email me, micah@therio.me. I'll drop it in the chat, and anybody's welcome to email me, by the way. Yeah, we'll jump on a phone call and I'll get you set up and all ready to go, and hopefully improve your patience and your practice, better outcomes. It's a good thing. So next question. I am presently on antifungal for mold and some powerful herbs for a parasite. Would it be best to hold off taking this test until the 3-month detox is over?
If you are confident in the detoxification protocol you've been given and you'd like to see it through, then absolutely take it afterward. If, however, you would like our test to help inform that protocol, or maybe offer some suggestions on how to alter it and make it more bespoke and tailor-made to your metabolic profile, then you should take the test now.
I think the perfect example is the one you used earlier, where the woman was started to take magnesium, so the medication for T3 free wasn't working. Like, that's a perfect example. If you're taking any medication to treat something, you should be taking.
Yes. Yeah.
No, another question. So this is a little bit longer because I have to fill in with this 2 comments here. But are you consciously balancing phase 1 and phase 2 liver detox? Can your test tell if you are unbalanced? And then I asked her for clarification. She said some people are fast phase 1 detoxes and phase 2 cannot keep up. Does this test take that into consideration? For instance, you can take sulforaphane supplements or increase sulfur-rich foods. But if you are not balancing detox, then you may not keep up with removal.
Yes, absolutely. So we look at, when we talk about phase 1 and metabolism and phase 2 metabolism, we do have metabolites that are very much in both realms. So when we look at something like proline, that's phase 1 metabolism that is involved and intricately implicated in cytochrome P450 metabolism. So that's your phase 1 metabolism. And also we also have its conjugate, 4-hydroxyproline, which is the product of phase 2 metabolism. And many metabolites are mirrored in that way in our panel, where there's a phase 1 and phase 2, not just for detoxification, but global cellular functioning also operates in the same phase. And so, yes, very much so. And we've curated this biomarker panel with an eye to be able to do that.
Okay. Another question here that's actually popped up a couple of times now, because I think because we're talking about environmental toxicities, right? And so how can we improve our bodies so that we can eliminate the trash that inevitably builds up? The question here, though, is about EMFs, electromagnetic frequencies. Does this show when EMFs affect the system? So to fill in, I would assume they mean, can you see if somebody's sensitive to EMFs? But I'm not 100% sure. And I don't know if Dr. Moore is good for that, or Dr. Jasbi.
I think you probably are.
The short answer is no. EMFs are something that has emerged in the biohacking space. There's some evidence to show that there are real effects of EMFs, and it's something that we are aware of and are keeping our eye on. However, for that to be included in both our detection panel as well as have recommendations ameliorating those effects, we need more science conducted on EMFs, and currently it is not as well scientifically supported, meaning that we need to establish a causal mechanism. We need to prove the effects of EMFs, generate a metabolomic signature, validate that signature, and then be able to, recommend interventions, again, that have been shown in the literature to be successful for that condition, which we've done for autism, which we've done for IBS, which we've done for early stage mild cognitive impairment, pre-Alzheimer's dementia. However, that is really contingent on the science and where scientists are looking, what they're publishing on, and currently there's just not enough to support that inference on our end for EMFs.
And as you guys know, the science usually lags behind something. We roll these things out and then we study it later is often what happens, especially if it's not like a medical device or something. It's just the Wi-Fi and that kind of thing.
I personally believe in the sort of underappreciated
Yeah,
effects of
100%.
EMFs. I do, but I need a model. I need a biomarker signature. I need validation in order to be including that in our panel.
Yeah, we need data. That would be kind of an interesting, just little for fun study to do, is just like get a couple boxes of rats. Some are living on a router, some are not. And what does their metabolic, the implication look like? That'd be kind of a interesting. I'm not a scientist, so that's a totally made up thing, but maybe you guys can figure that out in the future. I don't know. But yeah, I think that ran through. Let me see if there's any last questions. I'm not seeing any, but I really appreciate everybody jumping on today. Again, that discount, you have to use the link right here. It's available for 12 more hours. So by the end of the day, which is midnight Eastern Standard Time, that discount is no longer going to work. So if you want to get the test, understand your liver score, as well as a litany of other things, how your brain's functioning, or some early detection of what's going on in my body and what can I do about it. And then the most important thing, the personalized recommendations of how can I feel better? How can I live life better? Are going to come with that. And then of course, the free consult by one of the doctors on the health and science team. So again, use that link if you want to get the discount. It's available for 12 more hours. And I really appreciate everybody jumping on today. And thank you, Dr. Jasbi. Thank you, Dr. Moore. And thank you, Matt.
Yeah, I want to close this out. Do you mind, Micah?
Yeah, go for it.
I want to read an excerpt from the book that I really enjoyed after getting to know Dr. Moore and Dr. Jasbi. And I think when everyone's asking call to action, why do they spend all the time in the lab doing what they're doing? He had a great conclusion that when I read it, honestly, it struck me really well. He said, yet with promise comes he says, the future of healthcare shimmers with promise, yet with promise comes responsibility. The responsibility to heal, to innovate, to educate, and above all, make a lasting positive impact. Right? We embrace this responsibility with passion and dedication. In the tapestry of time, we are but a fleeting moment. Yet in this moment, we have the power to shape centuries. Let's stride into the future with hope, vision, and the audacious belief that we can and we will redefine the contours of global healthcare. The journey ahead beckons, and we're poised to answer the call. Loved it. Absolutely loved it. Gives me goosebumps even reading it.
Thank you, guys.
Yeah. All right, guys. We'll see you. Thanks again.
Thank you.
Bye-bye.